Hello everybody, welcome to Institute of Light Material in Lyon, growing crystal. So today I will introduce you to my laboratory and I will show you my activities regarding crystal growth, shaped crystal growth by micro pulling down and bulk crystal by Czochralski technique. But I will only focus on fiber crystal growth by micro pulling down. So let's go to show you our activities, to show you our crystal, to show you our technology, and I hope you will enjoy this presentation. Follow me. So now you are inside crystal growth laboratory. So before to start to explain to you how we grow single crystal fiber by micro pulling down, so I will present you a first presentation of our activities and the machine that we have to grow crystal, and I show you also some crystal that we have grown during the last 3 years. Here it is the office where people stay to work, postdoc, PhD student, engineer, technician, all they work here and they follow the crystal growth party. Here you see some crystal that we grow. But before to show you the crystal that we grow, I would like to show you our machine that we are using in the institute and also our technology. That is our Czochralski crystal growth machine. So with this machine we grow large crystal up to 10 kilograms. As you see, there is the box machine or the room. It is the chamber where we install inside the crucible, the raw material, the seed, and to start the growth operation. Here we have the generator. It is the source of the power which allow us to heat the crucible and to melt the material to grow the crystal. Here we have a cooling system, and our machine we use a gas atmosphere to protect the crucible. As you know, when we grow crystal, we use crucible, and crucible can be distorted and oxidized, so we need to protect the crucible, and it is the reason why we need to work in controlled atmosphere. Controlled atmosphere is like argon, azote, argon, hydrogen. It depends on the need, and also it depends on the application that we are working, and also it depends strongly on our needs and the performance that we are looking for. Here you see that is the arrival source of gas. You see we have argon gas, we have oxygen gas, we have azote gas, and the gas is very important, and because of security we don't put the bottle of the gas here. The bottle of the gas are outside. And here you see the different tube which connect the chamber to the gas arrival. And then after that, please see here, it is the computer source which allow us to heat the machine, and also which allow us to start the automatic growth by using specified software. That is a very short summary about Czochralski crystal growth machine that we are using for pulling crystal for the melt. This machine we can work up and we can grow crystal with a weight of 20 kilograms of mass, and also we can heat crucible and we can grow GAGG, we can grow sapphire, we can grow LYSO. So as we are using RF heating source, we have not limit of power. Please see here, for example, that is crucible that we are using to grow bulk crystal, and you see here we have all the heating zone, all the ceramic construction around the crucible. And for example here we put the raw material here, then after that we put the crucible inside the chamber. But before to start we have to protect the crucible by specific thermal insulation to don't lose the heat and to protect to heat and to use all the power necessary to melt material. And here you see, depending on the material, depending on the temperature, depending on the thermal gradient, for each crucible we have a specific thermal insulation. That is zirconia. You see, we have a different size, we have a different diameter. So depending on the size, we need a specific thermal insulation. But the most important, it is the crucible. As we are using RF, radio frequency heating source, the coupling by RF crucible is necessary to control the coupling. So this, it is the main important thing to use it for growing crystal. Then after that, I show you the crucible for growing Czochralski. Then another important things, it is the seed. The seed which allow us to connect and to find the good orientation. So it is very important. If we have succeeded the grout, after installation of the crucible, melting charge and starting the grout, we obtain crystal. How is it? Czochralski, when we finish the grout and everything is okay, and when we have used a crucible and a grout condition like pooling rate, all the parameters which allow us to obtain a good crystal, that is what we obtain at the end. You see here, that is the crystal that we grow, and that is the seed what we have used. The seed, it's the crystal that which allow us to obtain the crystal with the orientation which are needed. So the seed has an orientation which give us the orientation of crystal. And this is a crystal that we grow in this machine that I showed you before. To grow this crystal, it take about 10 days. And this is example of sapphire that we have grown. But I will show you some other crystal that we grow by Czochralski technique, is especially scintillating crystal that we are using for TWISMA project, and especially GAGG crystal. That is GAGG scintillating crystal. As you see, the color is yellow. It is because of cerium emission, and this crystal is a good scintillating material. It is used for high energy physics application, and this crystal is grown from the melt using iridium crucible, and I show you before example of iridium crucible. So to grow this crystal, it take about 2 weeks, including the heating step, the grout process, and the cooling step. To get a good decay time and to get a good scintillation properties, this crystal is co-doped with cerium and magnesium. The weight of crystal is about 2.7 kilograms. It is a good crystal. It is transparent. It don't contain defect such cracks and even bubbles, because we have already cut a piece of those crystal and we did some characterization. So now we are working also to prepare other composition, and it will be soon ground by Czochralski technique. This is a simple fiber ground by micro pulling down technique. It is YAG doped cerium. The longest it's about half meter, and this fiber it take 1 day to grow it. You see the color is yellow. It is doped cerium. And later I will explain to you the technology that we are using. It is micro pulling down, and the different steps that we use until we get a fiber like this. Now we are in the experimental room of micro pulling down technique machine. So in this room we prepare fiber or plates or tube using micro pulling down machine. That is our machine. The machine is composed of one chamber in which we put inside the crucible, the seed, and the material to start the grout, a generator to heat the crucible. It is the same thing like what I present to you before regarding Czochralski crystal growth technique. We use RF heating and we use this generator to couple and to heat crucible. And we have a software and we have a box to control all the automatic grout. We have also system pumping. It is in this box. And to fill out the grout, to see all the different steps of preparing crystal and growing crystal, we use a CCD camera. When we have a heat zone, we focus on this heat zone and route to TV. We can see the grout process and we can initiate and to start the grout. Now I will show you the inside of the machine. The machine is composed of RF spire, and here that is the inside of the chamber. As you see here, you have RF spire in which we create a magnetic field which heat the crucible. And here we have a seed holder in which we put the seed, and I will go to explain to you now the different steps to grow fiber by micro pulling down technique. With micro pulling down, we can prepare fiber or plates or other shaped crystal. It depends on the crucible design. I show you example of crucible which allow us to prepare fiber shape. That is micro pulling down crucible used to grow fiber of diameter 2 mm. You see here the capillary die shape which allow us to obtain fiber shape. The crucible we can put inside the material you see here, and it have a special shape. It was already designed to generate the shape that we need. That is, as I told you, example of fiber shape. But with micro pulling down technique, we can also prepare plates shape. I show you another crucible which allow us to obtain plate shape. You see here is example of crucible to generate plates of longest up to 10 centimeter, thickness to 1 millimeter, and largest about 10 millimeter. So here also it is special design which allow us to grow laser crystal or scintillating crystal or ceramic crystal. It depends on the needed application. And now I will also show you another important point to grow fiber or even plates. It is the seed. As I told you, the seed is very important tools which allow to obtain the orientation that we need. The orientation is very critical for the application. For example, there are some crystals which they have a specific orientation for specific application like laser or photonics or thermoelectric. It depends, or even some semiconductor materials. So here, for example, in laser applications, some crystal we need 111 direction. Some other crystal, in case of sapphire, we need C-axis 0001 orientation. So really, it depends on the needed. And the seed is very, very important because it fixes the orientation of the crystal that we would like to grow. That is the raw material. As you know, to grow crystal, we need material with specific composition. So that is example of raw material that we use. And this material, we put the material inside the crystal. And after that, let's start the preparation. That is the support that we put inside the machine. It is composed of quartz tube, and we put on the top 3 ceramics. We have to do it carefully, slowly, because if we don't do it slowly, we can cause some damage. For example, we can broken the ceramic, and we can get some trouble which will be not useful for the ground. Then after that, I will use small support of ceramic. It is alumina, I put here. Then I have to use an after heater. This, for example, that is we will use to grow GAGG crystal. It is an after heater with hole. The after heater allow us to control well the thermal gradient. We put the after heater here. We have to take care, slowly, step by step. Then after that, we take our crucible and we put it on the after heater, but we must see the capillary dye from the hole. And I put here, and with the lamp, I come to check if I can see the capillary dye. But now we are familiar and we have experience, so we know before soldering that everything is okay. Now I will show you how we use the ceramic insulation to save the power and the heat crucible and to control the thermal gradient. I close here with this tube. I put it here. Now you don't see nothing because the crucible is protected by alumina tube, and I close the top of the tube. We have a hole, and from this hole we heat, it become red. We use our CCD camera here. We focus it inside the machine, and when everything is melted, we take the seed, we connect it to the melt, and we start the grout. Now let's go to install everything in the machine. So I take the seed, I will install it inside the machine. Now seed is inside the machine. It is in the seed holder, you see here. And after that, I will try now to install the crucible. So I will go to take the quartz tube with the ceramic and I put it here. That is the tube quartz that I show you. That is the after heater that I show you, it is iridium. So now I put them inside the machine. So it is quite difficult. We have to take care because if we do accident, for example, if the tube quartz fall down, it will be broken. So we have to look for another one. So that is why when we do crystal, we only take time to do crystal. There is the RF. So now my tube, the quartz will go inside the RF and I install it. I have two movement, X and Y, to solder to seed holder. You have seen that I put the quartz tube and now I put the after heater. Then I will go to take the crucible. That is the iridium crucible that I show you. I will put inside the machine in the chamber, in the center of the RF and also on the after heater. Now my crucible and after heater are in the chamber. They are inside the RF. So now I will go to install the thermal insulation. It is ceramic based on alumina material. That is the ceramic that I will use to protect the crucible. So the crucible will be in the center of this tube. I start to put my tube, and I don't touch crucible, otherwise the crucible will fall down or will be inclined. And the crucible must not touch the tube, otherwise it will melt the alumina tube. So now I put the alumina tube, I take a lamp and I come to check if my crucible is in the center of the tube. That is the lamp that we are using. I come here and I see, and my crucible is in the center, everything is okay. Now I will close the top of the tube. Now my experimenter is ready. I can start to heat. We can start the grout. I close the chamber, so I will start to do vacuum. To start pumping, I push the button here, it is the green button. Now the pump is open, and it takes about 10 minutes to do complete pumping, and after that we put gas inside. I have a register, I have a tool to read the pressure inside. I will wait until the pressure will be 10-1. After that, when the pressure is 10-1, I start to put gas inside. Now we reach vacuum 10-1 millibar, so I will start to put gas inside the machine. I open here and I put gas. And I wait about half hour to have 1 bar of argon gas inside the chamber. After waiting half hour, now we have pressure inside the chamber is 1 bar. So I will start to heat. So as I am using RF heating, I need to put water inside the copper wire to cool it, and also as we are using RF generator, we have an oscillator, and the oscillator is cooled by water. So the first important things, I need to open the water. So the water is here. I open it. You hear a noise that the water is open. Then I will open the system of cooling water to work in closed system. And as it is water open, I will open generator. I will start the heating step. First, I prepare the data that I will use. We have, for each grout, we have a laboratory book. I use computer to create the data regarding the crystal that I will draw. The number of this experimental is 648. I will go to parameter and I put the number of the grout 648. I put OK. Then I will write all information about the fiber that I want to draw. I put the diameter, I put the mass, I put the density you see here, and then after that I save. Then I will go to the grout parameter, I will put the cooling rate and the total time for the grout process. And after that, I will put the maximum power of generator that I will use, it is security, and the step of cooling, I will put, for example, here, when it finished, we will cool within 2 hours. I save my data, and now I go to start to heat directly. After 1 day of grout, so now I will open the machine, I will collect the crystal, and I see how is it. Most of the at the beginning, I have to check. So everything looks okay, not problem, not damage. I take the crucible. That is my crucible. The good things, the crucible is perfect. We have not any problem. Crucible is not damaged, and the crucible is empty inside. So I have collect all the crystal, and I have collect all the raw material that I have melted. So all this raw material has been converted to crystal, which is still inside the machine. Now I will take the 2 quarts with the ceramic. Everything is okay. Now I try to collect the crystal from the seal. I will take a pencil to cut. That is the pencil that I will use to cut crystal inside. I cut, and that is the crystal that I grab. It is slightly yellow because it contained few amount of cerium, but the quality is good, and the crystal don't contain any defect. But we will do characterization to see and to be sure that the crystal has a good quality. So we have finished a good experimental of micro PD technique. It has taken for us 1 day, and you see everything is okay inside. So we can now prepare another crystal ground. So thank you for your attention, and let's meet soon.